All right, guys. We've studied quite a bit of stuff. Good review so far. Chapter one. You guys come close to the first test, and one thing that's going to be on there is a question about circles. So I kind of want to go over some circle questions and concepts before we move on. Now, this is the center at radius form of an equation of a circle right here. I accidentally put a square root. You can see the white out. But I don't know why. It was just so. I guess the distance formula was still kind of in me. And if you notice, it looks very similar to the distance formula. So what you need for this is you would want to know the radius, and you would want to know the center point. Okay, that's why they call it the center radius, right? So the center point's right here. We say that it's h some x h, right, and then some y k. So thus we have h and k right here. Okay. Now, a little key thing to remember that if this is a positive, like say this is three, h is three, this would actually look like that. Now, if h had been somewhere over here, right, it would have been a negative. Let's say I don't know why I put so it would look like that. Okay. Now, if this had been like say over here, and it will say negative four, this would actually look like this because the formula itself has a negative. Okay, so that general form has a negative, so you have to be cognizant of that. Okay, so if it's three, if it's negative three on the inside, that means it's a positive over here. If it's a positive on the inside, that means it's actually a negative. Okay, so and we're gonna go through some of these. So like let's take example number one. Okay, don't mind my finger right there. Okay, so we have x minus plus y minus, and that's going to equal to our radius squared, right? So in this case, this is our h and this is our k. So right here, we would put a 2, and right here we would put a negative 2. And in this case, we would go x plus, sorry. This would be x minus 2 squared. But over here, because we have two negatives, this would be y plus 2. And our radius was 10, so it would be 10 squared. And then, so our form would be 100. So when we're doing this one over here, we're doing the same concept. So we would do x minus h plus squared, y minus k squared equals r squared. So that means this would be minus 7 squared minus 2, and then 12 squared. So then we would have x plus 7 squared plus y minus 2 squared equals 144. That's it. All right, guys. So one thing that you guys got to stay cognizant on is that this says radius. So a lot of times they'll give you a problem like this, they'll give you a second problem like this, and then the third problem would be something like center of 1, 2, and diameter of 24, right? And then you go about your business, right? And you do this whole shebang, right? Bam, and then you go bam, and then you go 24 squared, and then that's a big no-no. Because remember, this is not, you don't put the 24 here because it's asking for the radius, right? So technically the radius is not 24. The diameter is 24. So that means this would actually be 12. Okay, so be careful. So they'll give you radius here, they'll give you radius here, and then bam, they'll give you diameter. All right. And another thing also is sometimes you don't even have to square it. So you could just leave it. Oops. You could just leave it 10 squared. Okay. You could also like this one could also be left. Okay, 12 squared. Right. Um, so this is correct in my book, and this is also correct in my book. Right. Um, it just depends on what they're asking, so you got to be careful. So if they ask you for the form, I I would leave it like this. If they ask you for the most simplified form, so like you would kind of just square it. But this is big, guys, right here. Make sure you guys are looking at whether they give you the radius or the diameter, because that's gonna throw off a big chunk of your answer. You know what I mean? So be careful with that. All right. Now, this is the type of question I like right here. These are my favorite ones, dealing with circles. So, what if they don't give you the center or they don't give you the radius? What if they give you so they give you a circle, right? But they give you the endpoints of the diameter. Well, the whole cool thing about this is that we were studying midpoint and distance formula. So, if we wanted to, we could get the distance of this diameter. We could figure it out, but we don't need that. What do we need? We need the center and we need the radius, right? Well, wouldn't the center just be midway between the diameter? Because we know diameter cuts the circle in half, right? So that means if we find the midpoint, we find the center. And that's exactly what we just did last class, right? The last video. So right here, we get our x's and we add them. We get our y's and we add them, and then we divide by 2. So in this case, our center is 0, 1. Okay. Now to find the radius, we could do either one. So we know the radius will either be this part, right? Or we could do this part. It doesn't matter. Either one is going to be the radius, right? We could also just get the distance between the endpoints and divide by 2, right? We could find the distance and divide by 2. Whatever works best for you, right? So in this case, what I did is I used my center point and I used, let's say this was negative 0, -4, and this was 0, 6. Okay, I didn't draw the axes, but like let's just suppose. So I just chose this point and I chose this point. Okay, so I get my two x's and I subtract them, and I get 0 minus 0. Then I get my two y's and I subtract them. So in this case, it's 6 minus 1. 6 minus 1 is 5. 5 squared is 25. 25 plus 0 is just 25. The square root of 25 is 5. So my radius is 5. My center was 0, 1. And that's all I need, guys. So now I put x minus 0 squared y minus 1 squared equals 5 squared. Now, again, we could simplify this a little bit, so we could make this one just say x squared. And we could write 25, or we could just keep it 5 squared. Okay? So I really like these type of problems because it kind of uh, builds off everything that we've been learning, right? We've been learning midpoint, we've been learning distance, we've been plotting points, we've been doing a lot of this Pythagorean theorem, right? Well, like all these little concepts are now rolling into one. So let's do a couple more problems. So right here, so we have two endpoints, and we want to figure out the the circle, right? The equation of the circle. So let me zoom in a little bit. So first, we do the midpoint. So let's get our midpoint first. That midpoint will be my center. So I get my x's and I add them. divided by 2, divided by 2. This becomes -4. -4 divided by 2 is -2. So this is my center point. So now to find the radius, I pick my center and one of the endpoints. It doesn't matter which one, but I pick one of them. And I find my distance formula. So distance equals bap, 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 bap. So I'm going to say this is x2. So it'll be 2 minus 0 minus. And then I pick one of these points. So it'll be 3 and 0. So this becomes -5 squared. This just becomes 0 squared. So another 25 squared, which is 5. And this was our distance, but in actuality, we're finding the radius, right? Because that's from the center to the end point. From the center to the end point is the radius. So now we have our equation. So we have our equation. We have everything we need for our equation. So we go x minus our center point, so minus 2, plus y minus 0, squared, equals 5 squared. Right here, this becomes a plus. I don't need the 0 there, and then 5 squared. And that's our equation. Really, really like these type of problems. I really do. We do this one over here. Same thing. Let's get our midpoint first. Our midpoint will be our center, right? So we go 3 plus 3 divided by 2. We go 4 plus -4 divided by 2. So this is 6 divided by 2, which is 3. 0 divided by 2 is 0. Very nice. So now I pick one of these points and one of these points. I have to pick this point and one of these points to find my distance, find my radius. So my radius would be, I'm going to use this as my x2. So it would be x2 minus x1 squared, y2 minus y1 squared, and all of that is square rooted. That's my distance, but in this case, we're actually finding our radius, right? So I'm going to have 3 minus, I'm going to use this one, 3 squared, 0 minus 4 squared. 3 minus 3 is 0, so I'm not going to even worry about that. -4 squared is 16, so this gives me 4, and that's my radius. Because remember, I know we're doing D for distance, but we're finding the distance between the center and an endpoint, which is actually our radius. Okay? So now we have our radius, we have our center. Our center was 3, 0. So let's build our equation. So BAP. We could simplify this right quick. We don't need this 0. And that's it. Ain't nothing to it but to do it. So now on this one, we were doing completing the square earlier, and earlier this year, right? When we were doing quadratics. Now you see, we did distance formula earlier, and it came back. We did midpoint formula, and now it came back. It's in this circle section. We did completing the square, and it's also in this circle section. So sometimes they'll give you this general form, right? So something that looks kind of crazy out there. They give you x squared plus y squared plus some dx plus ey plus a number, and it all equals 0. And you're like, what? All this stuff equals a circle, and Yeah, it does. It really does. But we have to do some minor adjustments that makes it look more like this, right? We want it to look like this. We want it to look like, where is it? Where is it? Where is it? Where is it? We want it to look like this because this is something that we're familiar with, right? This that looks easy for us. We could see the center. We could see this the square, the radius. So we're right here. So what we want to do first is we want to group our our variables. So I want to group my x's together. So we have x squared and 4x. I'm going to group my y's together. So I get my y's right here. And what I also want to do is I want to push all the numbers that are by themselves on the other side of the equal sign. Okay, so I pushed this plus 7 over, so I got a negative 7. Now I do that because I'm going to complete the square. And when I complete the square, I only want to complete the x part first and then the y part. And what I do on one side, I have to do to the other. So to complete the square, guys, I take this middle term, this negative 4x, I cut it in half. And whatever that half is, I square it. So negative 4 divided by 2 gives me a negative 2. I take a negative 2 and I square it. Negative 2 times negative 2 gives me a positive 4. So this little blank I left, I add 4. But what I do to one side, I must do to the other. So I added 4 to this side. And it just so happens for the y, it's the same concept, right? I take this middle term, okay, this 4y, cut it in half, square it, I get a 4. Okay, so I added 4 here, and I added 4 here. Now, why is this important? Well, this is important because now I can factor this. I know what the two numbers that give me positive 4 here, but when I add them, give me negative 4. And that's my x minus 2. So it's x minus 2 squared. In this case, it would be y plus 2 squared. And then when I add these, negative 7 plus 8 gives me 1. So now it's visually appealing that I know what my center is. I can see it right there. I know my radius. It's right there. Actually, I forgot something. This should have a 2, right? Oh, wait. So, wait, that brings me to a question. So, right here we added, right? So we had 1, but we always have our form like this. We always have it in um I guess r squared form, right? So if it's just 1 by itself, would it be 1 squared or would it be square root of 1? So to finish it off here, right? Um, this is what we're doing. So we know that this is 1, but we also know that this is actually equal to r squared. So technically, we would take the square root of both sides. Square root right there gives us our radius. And what's the square root of 1? Well, what two numbers give us 1? Well, 1. So here, it stays the same. So it's not this one. Well, it's kind of like that one. It's just this number is just it's one of those special numbers, right? 1 is kind of cool like that. So let's move on to another problem so we can see this out. So let's take this problem. We have the almost identical problem, right? We have x, we have the y squared, we have this, we have this, we have all these numbers. But one thing that they all have in common is they are all actually we could actually reduce all of them by 3. So this actually could be x squared, y squared, minus 10x, minus 4, plus 4, okay? So then I group my letters my x's together, my y's together, and then I'm gonna move this 4 over, so this becomes a negative 4. Okay. Bop, bop. Now, right here, I complete the square. So, half of this is negative 5. Negative 5 squared is 25 plus 25. Then over here, half of negative 4. Because remember, we take this middle number, we go negative 10, go half, and then we square it. So this becomes negative 5 squared, which is 25. And we're doing the same thing for negative 4. We take half of negative 4, and then we're going to square it. So negative 4 divided by 2 gives us negative 2. Negative 2 squared gives us a positive 4. But here's the kicker. Because I added a 4 here, and because I added a 25 here, I have to add them on this side. Okay? So on this side, well, these cancel, and I'm left with 25. And because I know that this is now going to be just y minus 2 squared. And this is going to be x minus 5 squared. Because I know those numbers. The numbers are these right here. Oh, forgot the plus sign. And that's my general equation. Sorry. So what did we do over here? Remember? What did we do over here? We took the square root. So we can have it in the r squared form, right? So we could find our radius. We take the square root. So that means we take the square root, and our radius would be 5. So our center is 5, 2. Our radius, whoops, is just 5. Okay? So now, if we wanted to do this one right here, zoom out, we could do the same steps, right? So here we can't reduce anything, but we could combine the x's together, the y's together, and then again, I'm going to push this negative 1 over here. I complete the square. So right here would just be 4, because I mean this, we've been using that 4 a lot, and this one would be what number? Cut this in half. 2 divided by 2 is 1. 1 squared is just 1. So that means I have to add a 4 here and I have to add a 1 here. Okay? So this just becomes x plus 2 squared when we factor it. Actually, no, we're not. Yeah, it's kind of factoring. Y plus 1 squared. And then these will cancel, leaving us 4. But remember, we take the square root. We always have to take the square root, right? So square root of 4 is 2. So our center, in this case, would be negative 2, negative 1, and our radius would be 2. And remember, it's a negative 2, negative 1 because our formula is always x minus h and y minus k. And because it's the formula is here and this is positive, that means it had to have been double negative. So when I input this here, the two negatives become a positive 2. So you guys kind of remember that. Okay? I really like these problems because it involves completing the square, and that's always good to remember. What's left? Ooh, this is kind of like this problem is kind of like a how do I say it? A glimpse into the future. So We're going to be doing systems of equations, right? And a system of equation is whenever you have a graph, right? And you have two lines. Let's say you have a line going this way, and then you have another line going this way, right? And you want to find out where they intersect, right? Where they intersect is your solution, okay? So that's the concept that's happening here. But in this case, we don't have two lines. We have a circle and we have a line. And what you want is you want to find one, at least one, or both. If you can find both, that's even better, of the intersection points. So this is going to be like a total bonus problem right here. All right. Um, I'm gonna set it up for you guys. So we have our center and we have our radius. So that means we could set up our equation of our circle. So that means x is 0. So that means this is just x squared, right? Because if I put zeros, it doesn't do anything. And then I put the 4 here, so this becomes y minus 4 squared. And then this becomes 3 squared, which is just 9. Now, what do we do with this other line? Well, we know for a fact that the line is this right here. 1/2 x plus 4. And what happens is this line has to touch this circle. So that means there's a point, well, actually 2 points, right, where they're exactly the same. So that means this y would be equivalent to this y because it would be exactly the same. So that means I could literally put this for this y. Okay? So I would have actually x squared plus parentheses 1/2 x plus 4. That's just this y. All of this is going to go in there. Minus 4 squared equals 9. Well, check this out. This begins to cancel. Then we're just left with 1/2 x squared. So we have x squared plus 1/2 x squared equals 9. Right? We could go a little further. And what happens when we add these two? This becomes 3/2 x squared equals 9. Oh. Back up the bus, back up the bus, back up the bus. Back it up, back it up. The squared not only went to the x, but it went to the 2 as well. So it's 1 squared, 1, which 1 times 1 is 1. 2 squared, this is actually a 4. Back up the bus. Ooh, little minor mistake right there. So it's a 4, right? Because remember, we're going 1/2 x squared. So that means we put that to the 2, to the 1, to the x, and to the 2. So it's 1 times 1, 1, 2 times 2 is 4, x squared, x squared. Okay. So now when we add these, this would become 5/4 x squared. Now you're probably thinking, man, I don't want to do with fractions, but it's all right. It's not too bad. To get rid of a divide by 4, we multiply by 4, multiply by 4. So now we have 5x squared equals 36. Divide by 5, divide by 5. X squared equals to 36/5. I now take the square root. So we have x equals to the square root of 36 over the square root of 5. Square root of 36 is just 6. I don't know what the square root of 5 is. But luckily for me, I have a calculator. And I get this decimal of I'm gonna go to the third decimal place. So I'll get 6832. Going to this decimal place, so I'm just gonna write 2683. Okay. Now you're probably thinking, what? So that would be kind of like this point right here, because this is positive x, right? But we still need to know the y. But we already know an equation for y. So all we have to do is plug in this point into this y. And that's kind of like what we would do in the systems of equations, right? From algebra 2 or algebra 1. We set them equal to each other, solve for one letter, get whatever that letter is, and we plug it back into one of the originals. And then when I do that, so I'm going to plug in this right here into that one. So I have y equals 1/2. I'm actually going to plug in this because I'm going to get more of an exact number, right? So this is x as well. So I just plug that in, right? And uh, I get, you could actually just go 6/2 square root of 5 plus 4. Or the decimal would be 5.3416. But I'm going to go to the third decimal place, so I'm going to put 5. Whoops, no, let me put it below it. 5.342. So one intersection point is 2.683, comma 5.342. Now that's one. What I want you to do is this is strictly a bonus. You guys, I got a couple emails from the last bonus. This is strictly a bonus. You find that second point. And I'll give you 5 points bonus. Okay? So this line goes through this circle twice. Okay? I want you to see if you can find the second point. Okay?